Mathematical Practice 5. Use appropriate tools strategically. The standards for mathematical practice, often called the mathematical practices or the math practices, can be found on pages 48 through 50 of the College and Career Readiness Standards for Adult Education. These practices describe behaviors and thought processes that support mathematical thinking and reasoning. So that students have experience with all 8 practices, it's the role of teachers to encourage the practices and incorporate them into activities. This webcast will highlight Mathematical Practice 5, Use Appropriate Tools Strategically. So, to begin investigating Mathematical Practice 5, let's listen to Marisa and Will discuss using appropriate tools strategically.
Hi, I'm Marisa, and this is my friend Will, who's a carpenter and building project manager with Terra Firma. We're going to shed some light on Mathematical Practice 5, Use Appropriate Tools Strategically. So Will, how do you decide what kind of a tool to use for a particular job?
Well, I have to assess what needs to be done first, because different projects will require different tools. So if I'm doing demolition, I might need a certain set of tools, like pry bars or sawzalls. But if I'm building, if I'm actually framing, then I would use tape measures, nail guns, screwdrivers, different things. So really what I need to do first is assess what tools or what job needs to be done so I can use the most effective tool.
Okay, so you need to be familiar with a wide variety of different tools and what they can do.
Yeah.
Okay, great. Well, let's go look at some examples.
Cool.
So, when people think of carpentry tools, they usually think of things like hammers and screwdrivers, things like that. But are there other kinds of tools that you use on a regular basis?
Yeah. Quite often we just use previous knowledge that we have or other skills that we've learned. Those work as tools just as well. For example, you may be wanting to measure a room, but you can either use a tape measure for that, but if you don't have a tape measure, or if you're trying to speed things up, you may just use estimation. I know this room is about 12 feet, so you can estimate it. Also, if you're trying to check a room for being square, you can use a framing square, but it'll only get a little bit of the room square, as opposed to using math skills like the 3, 4, 5 triangle method, where you measure things 3, 4, and the hypotenuse 5 to find out if a room is square. Those sort of things would be considered tools as well.
Mm-hmm. Great. Well, do you ever get stumped by a certain situation?
Yeah, quite a bit. But there again, you can use, it's awesome to be able to check online. Google things is great. You can also call a coworker or a friend who might have previous knowledge, or use previous knowledge of projects that you've done and things that have worked on those, or even reusing tools in different ways to be creative. Like if you're cutting a material like this threshold and you're finding that it's splitting a little bit, maybe you use a metal blade instead to get a little bit of a cleaner cut. Just a way to reuse tools in different ways.
Okay, so when you want to choose the appropriate tool, you need to know both the main purpose of it, but also kind of the various capabilities that each tool might have.
Yeah, it helps you to choose the correct tool for that job, and it makes the whole project be a little more efficient. It makes your day go a lot easier.
Great, well thanks a lot, Will.
Hey, no problem, thank you.
Now that you've got a sense of the meaning of this practice, let's look more deeply into what it means to use appropriate tools strategically. I'll highlight 3 features of this mathematical practice, as well as example activities at different levels that work with each feature. All of the math content examples that I share can be found in the College and Career Readiness Standards for Adult Education. When you work with Mathematical Practice 5, you'll be guiding your students to consider available tools when solving a problem, recognize the benefits and limitations of those tools, and identify and use relevant external mathematical resources. To encourage learners to consider available tools when solving a problem, you could ask them, "What tool could help you solve this? How will it help you?" For example, how many 2-pound packages of ground beef will you need to buy in order to make 10 quarter-pound hamburger patties? At a lower level, when asked to solve this word problem, some students will reach for a calculator, others will want to do a sketch or do computation with pencil and paper, while others will use the quarter circle manipulatives that are provided at their table. At a higher level, when given the function y equals -3x plus 9, students could be asked to find the value of the variable in each of the given ordered pairs. Some students will reach for pencil and paper in order to solve this using substitution. Some will also use a calculator for computation during the substitution process. Other students will see that they can set up a spreadsheet that can quickly find the values of several ordered pairs and use that as a tool to answer this question. By encouraging learners to consider available tools when solving a problem, you'll see them assess, value, and become more skilled with the tools that are available to them. Now, let's continue to the second feature. To encourage learners to recognize the benefits and limitations of tools, you could ask them, which tool will give you the information that you need? Which tool will help you solve the problem efficiently? For example, at a lower level, when asked to divide 11 by 3, it would be understandable to see a student reach for paper and pencil. However, when exploring how changing the number of repeating digits after the decimal changes the product when checking their answer, they would see the limitation of the paper and pencil in that it would be very time-consuming and would choose a calculator as the appropriate tool for this task. At a higher level, when determining the amount of fabric needed to make a tablecloth, a student could measure with the span of their hand, knowing it was about 7.5 inches across. When determining the amount of plastic used to make the lid of a plastic soda bottle, though, because of its size, the more appropriate tool would be a ruler or tape measure. The benefits and limitations of tools can be evaluated on criteria like efficiency, accuracy, and ease of use. By encouraging learners to recognize the benefits and limitations of tools, you'll find that you will see them be empowered to use the tools around them as they work to solve math problems. The third feature of using appropriate tools strategically is identifying and using relevant external mathematical resources. To encourage this, you could ask, where could you find that information? Where could you learn more about that? For example, at a lower level, students could find and share videos on YouTube that show methods of adding and subtracting fractions and then share them with the class or small groups. Students could evaluate the videos based on criteria that you create as a class. Here is an example of a video evaluation sheet. Students could watch for focus, accuracy, conceptual understanding, a clear explanation, an appropriate length, and an enjoyable watching experience. At a higher level, students could use their smartphones as tools in the problem-solving process. For example, they could look up definitions or unfamiliar math terms or higher-level formulas that they need. If different students found different definitions or different versions of the formula, you could discuss those differences. They could also use graphing apps to explore how the graph of a line changed when its equation changed. By encouraging learners to identify and use relevant external mathematical resources, you will see them become more independent in their own learning process. Each of the previous examples illustrates how students could use appropriate tools strategically. Now let's watch these students use appropriate tools strategically as they reason with three-dimensional figures.
In the lesson with her Year 9 group, Aisling introduces a 3D problem.
Okay, this is Joey's box. And Joey is having a bet with his friend Jasmine. And the bet is about what is the longest stick that would fit into this box. So what I want you to do for a moment, I'm going to pass some boxes around, is have a little chat with the people around you and try and figure out what you think the right answer might be for a box like this.
So how long do you think that this is, like the length of the rectangle is?
So like we could put a line through it. We work out the length of this one, then we know like how long the stick can go in there.
We can use Pythagoras.
Measuring it that way is going to have a longer stick than measuring forward like that. So we're going to measure it that way to see how long the stick can be.
They then look at an interactive version of the same box made on the software.
Thank you very much, Vivian. Okay, so Vivian has actually opened up the box so that we can see inside of it. This line, which is one of the sides of our cuboid, is 8.2 centimetres, whereas the diagonal is actually 9.9. Right, is that the longest stick that could fit in, do you think, into this box at 9.9 centimetres? Do you have another idea for me?
You can measure from E to C.
From E to C, right. So then you're actually finding the diagonal from the top vertex to the bottom vertex of the cuboid. So if we measure the length of that segment, 11.5. Well done. I'm going to rotate the shape so we can have a look at it from different angles.
Is it triangle?
Does anybody have anything they want to mention? Denai?
Yeah, you can see a triangle inside of it. I think it's from points E, G and C there.
So you want me to go from point E to G to C. Okay, let's rotate that and have a look at it. So if we don't know this length here, how can we work out what it is? Elise?
To find the length, you could use Pythagoras theorem.
So we know that, for example, this side is 5.5 and this side is 8.2, so we can work out what EG is. Once we know EG, we already know that from G to C is 6, so we can use our value from EG and GC to find the length of the longest diagonal. So in fact, in this problem, we have to use Pythagoras twice. Okay? I want you to try that out with the person beside you now, please.
Although the software can give all the measurements automatically, Aisling believes it's important for pupils to back up what the software can do with the written methods they're expected to use in the exam.
We're trying to work out the pink triangle at the top first. Find the hypotenuse. So it's 5.5 and 8.2.
Yeah, 5.5, 8.2, and the hypotenuse
Equals C squared. 8.2 squared is 67.42.
How did the students in the video demonstrate that they were using appropriate tools strategically? Did they consider available tools when solving a problem? Did you see them recognize the benefits and limitations of tools? Did they identify and use relevant external mathematical resources? All three features may or may not have been demonstrated in this particular video. What other mathematical practices did you observe? Feel free to pause the webcast while you think about or discuss these questions. The students in the video were asked to reason about a three-dimensional figure. You could ask your students to do a similar activity. The figure that you choose and the questions that you ask about it could be modified to fit the level of your group from beginning through high school equivalency level. Also, you could ask a more open-ended question to a multi-level group, allowing each small group to approach the question with the math knowledge, skills, and tools that they have available to them. In conclusion, I want to ask you to think about the tools that are available to your students as they work to solve problems. If they will need to use tools like calculators or personal dry erase boards when they take tests, make sure that they are able to become experts with those tools in your classroom. Here is a poster that summarizes Mathematical Practice 5. Use appropriate tools strategically. The next slide shows the link where you can download the poster to print and post in your class, as well as links to all of the other resources used in this webcast. How will you encourage students to use appropriate tools strategically?